Hey guys, this is Coach Lowe, and we are going to talk about areas of regular polygons. We've talked about areas of the triangle, the trapezoid, of course, square and rectangle. So now we're just going to talk about regular polys. So as we're talking about regular polygons, remember what a regular polygon is. All sides are the same length, all angles are the same measure. It's convex, so remember concave means it looks like it's been punched in on a side, so it does not look that way. And so those are the types of figures we will be finding the area of. All right, so let's get started. Let's grab, how about pentagon? All right, so we have a regular pentagon. A regular polygon has a center, and this center is equidistant from all the vertices. All right, so it's a point on the inside. So a point on the interior equidistant from every vertice. All right, or I should say vertex, huh? Come on now. I'll put from all vertices. That's better. Even better. All right, so that means this distance is equal to 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 this distance, all the same. Okay. Also, there is a line that we can draw perpendicular from the center, perpendicular to any side. All right, so perpendicular to any side, and it's called the apothem. Okay, I can't spell, obviously. Thinking and writing at the same time, probably a bad idea. All right, so it's called the apothem, and it is, well, any of these that I draw to the side, perpendicular to sides, will also be congruent. They'll be the same measure. All right, this is a very important segment because we can actually find the area of this entire figure using this apothem. The area of the figure is 1/2 times the length of the apothem multiplied by the perimeter of the figure. Now I'm going to show you why, and we'll do an activity in class, of course, as well, but let's look at why. All right, so if I draw the apothem in, and that's the height here, and then I draw this guy, do you see that that's a triangle? If I know the length of this, then I can find the area of this green triangle. So area of the green triangle is 1/2 base, and we'll just call this a side, 1/2 base times the height. You guys agree with that? Area of this green triangle right here is 1/2 base, which is S, multiplied by the height, which is A. Well, if I can draw congruent triangles through here by finding the apothem and then making triangles by drawing segments from the center to each vertex, then how many triangles would I have? Well, here's 1, that would be 2, 3, 4, and then 5. So the area of the entire figure would be 1/2 the side times 5, or let's do this, even better, would be 5 of those 1/2 SAs, right? It would be 5 of those green triangles, 5 of them. All right, now here's the cool thing. 5 times S is actually the perimeter. So here's S, 1, 2, 3, 4, 5, gives me the perimeter. That's this guy. So they stuck the 5 and the A together and made it perimeter. So it doesn't matter how many sides the figure has, 6, 7, 8, 9, 10, whatever. We can use this formula and just find the distance from the center to an edge of the polygon, perpendicular of course, so that distance, and then multiply that by the perimeter, take half of it, done. All right, but that's where it came from, drawing triangles inside this figure. So the P comes from, there are 5 sides on this one. That's where that's coming from. All right, and we'll do an activity to kind of mush all that together. Okay, so if a regular polygon has an area of A squared units, an apothem of A units, and perimeter of P units, then this is the formula. So if a polygon has the area of A units, an apothem length of lowercase a, and perimeter capital P, this is the formula that we can use. We should be able to find the perimeter if they give us a side length. We should be able to find the apothem. We can plug and chug that out. All right, let's try one. Let's do a regular octagon. All right, so here's a regular octagon. If you want to pause the video and go ahead and draw your octagon, that's a great idea. There's my apothem. And its length is 10.9 inches. And this is 9 inches. And the question is, what's the area of this octagon? So to fill in the inside, what's its area? Well, we know the formula is 1/2 S times the perimeter. All right, so area equals 1/2, I'm sorry, not SA, my bad. 1/2 times the apothem multiplied by the perimeter. Well, we know the apothem, the distance from the center to the side perpendicular to it, is 10.9. And the perimeter is, well, if one side is 9, then all sides are 9. And how many sides does an octagon have? Yep, 8. So the perimeter is 8 times 9, or 72 inches. So we'll plug in 72 for P. So now we can multiply these. 1/2 times 10.9 multiplied by 72 is 392.4. And that's in inches, so we have inches squared because we're talking area. This was in inches, that's in inches, square inches after that. All right? Okay, let's say from here that they just want to know this region right here. What's the area of the shaded region? What's the area of that shaded region? Well, we know the area of the entire thing, so a couple of ways to do this. We can find the area of one triangle and multiply it by 2, or we have the area of the whole thing. How many triangles out of 8 are over here? So hopefully you could see 8 triangles here. So how many triangles out of 8 are shaded? 2. So we can multiply this by 2 and then divide by 8, or you can multiply by 1/4, either way. All right, so let's do that. 392.4 divided by, I'm just going to go ahead and divide by 4. 98.1 inches squared. So this is shaded area. All right, so I reduce this to 1/4 and multiply by 1, divide by 4, and that gives you this blue shaded area. All right. Now, there are other things that they can do, and we'll look at some of these in class. Like they could break this off and talk about trapezoid here, like this shaded area. So lots of different things that could go on, and we'll look at some of those crazy ideas in class. But for now, That's about it, guys. So make sure that you have all these notes. This is through 10.4. 10.3 we did in class yesterday. So this is Coach Lowe, and I'm out.